Hello guys, my name is Paul Matibag and welcome back to my YouTube channel, and we are here now to answer the activity in chapter 5 Ethernet in 5.2.1.6 activity switch it. If you can see, they have Ethernet frame, then MAC table and switches, devices, hub, and other two devices connected. Okay, let's start. Instruction: determine how the switch forwards a frame based on the source MAC and destination MAC addresses and information in the switch MAC table. Answer the question below using the information provided. So first, the preamble is 7 bytes, also called the start of frame. Fields are used for synchronization between the sending and receiving devices. These first 8 bytes of the frame are used to get the attention of the receiving nodes. Essentially, the first few bytes tell the receivers to get ready to receive a new frame. Okay, the destination MAC is 6 bytes field is the identifier for the intended recipient. As you will recall, the address is used by layer 2 to assess devices in determining if a frame is addressed to them. The address in the frame is compared to the MAC address in the device. If there is a match, the device accepts the frame. Can be a unicast, multicast, or broadcast address. Then the source MAC, this 6 byte field identifies the frames originating NIC or interface. Must be a unicast address. Then the length type, this 2 bytes field identifies the upper layer protocols encapsulated in the Ethernet frame. Common value are in hexadecimal 0 times 800 for IPv4, 0 times 6 times 86 DD for IPv6, and 0 times 806 for ARP. Then and data or encapsulated data. This field contains the encapsulated data from a higher layer, which is generic layer 3 PDU, or more commonly an IPv4 packet. All frame must be at least 64 bytes long. If a small packet is encapsulated, additional bytes called a pad or used to increase the size of the frame to this minimal size. Then the last one is frame. is used to detect errors in a frame. Is use a cyclic redundancy redundancy check. The sending device includes the result of a CRC in the FCS field of the frame. The receiving device receive the frame and generate a CRC to look for errors. If the calculation match, no errors occurred. Calculations that do not match are in indication that the data has changed. Therefore, the frame is dropped. A change in the data could be a result of a disruption of the electrical signals that represent the bytes. And the Mach table is F1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So 0A is connected to FA1, and then 0B is connected to FA3, then 0C is FA5, and then 0D, which is on source Mach, connected to FA7, and then the hub connected to FA9. Okay, question 1. Where will the switch forward the frame? FA1, then FA3, then FA5. FA7 is not included because OD is source Mach. Then FA9. Then when the switch forwards the frame, which statements are true? Choice 1 is which the source Mach address to the Mach table. Frame is a broadcast frame and will be forwarded to all ports. Frame is a unicast frame and will be sent to specific port only. Frame is a unicast frame and will be flooded to all ports, and frame is a unicast frame but it will be dropped at the switch. I think frame is a unicast frame and will be flooded to all parts. Then let's check. And you successfully answered all questions based on the information in the frame and Mach table. So I think that's all for chapter 5.25.1.6 activity switch it. And then thank you for watching. I hope you enjoyed. Bye.